All right, let's go ahead and get started. Welcome to class. I'm going to go ahead and close this, but if you see anybody knocking, let me know. All right. So I had all these slides updated right before coming to class, and then my other computer crashed because technology hates me. And so I don't have off the top of my head the exact numbers, but it's something to the effect of the average on the last exam was a 90. The median was a 92, I think. The standard deviation was about 8 points. And there was a negative skew to the data. If that's your jam to know all about that. Questions about that last exam? For some reason that felt like weeks ago. And so when I started analyzing it, I was like, am I having a stroke here? What's happening? But questions, concerns about the last exam, feedback to me about the last exam. Casey says, will that exam format be similar to the final exam? I don't remember what I've used for the final exam in the past. It will likely be kind of a mixture between exam 1 and exam 2.
The final is cumulative, right?
Correct. Yes, ma'am. It is going to be a lot of information.
And then we go eyes or ears on there. Yeah, I also got it.
Oh, you mean like the anatomy? I was like, what? I thought you were asking for no more than that respondus, like Big Brother thing. But,
oh my God, no. It gives me such anxiety. Like, when someone will cough in my house, and then I'm like, I'm being watched.
I'm being watched. Yeah. Yeah, I need to figure out what the right answer is. Because as an individual, I don't like that. But whatever.
What makes you self-conscious? Because like I like to read the questions to myself
Oh, I talk to myself before.
and so I'll be like mouthing things, and then I'm like, crap. Like I'm
No, I talk out loud the whole exam. Watch my playback. I read all the questions. I say all these words. I'm like writing weird things.
Good news is where it flags it, I just go look, and it's never an issue. So
I just like I explain myself because it seems I'm doing it here. Like I'm not doing anything wrong. Let me just say this part before I do anything that looks sketchy.
yes, I don't know if y'all have read 1984. If not, you need to go read it. But it does feel like at this point, school and life is very similar to a lot of that surveillance type state there. Where I have to explain I'm not having any thought crimes here. All right. Here is your fun fact of the day. A crocodile can't poke its tongue out. How about that? So this is normally where I would pull up a video and show from I Love Lucy, an assembly line scene. It's very funny. Just go watch it. But it's such a pain in the tuchus to bounce back and forth between the iPad and the computer that I'm not going to play it. But because we were talking about stress and workload today, I think it is a very apropos video. All right. So today we're going to start talking about stressors. And when we talk about stress, stress can be related to a multitude of things, but kind of the big 4 categories when we talk about stressors are stressors from the environment, stressors from physiological arousal. And so when I say arousal in the context of this class, what I mean is increase in heart rate, increase in blood pressure, increase in respiration rate. I'm not talking about sexual arousal. It's purely the physiological heightened arousal. Also, stressors related to health. And stressors related to experience. And these stressors can be either direct or indirect. Right, so the stressors themselves can directly impart that stressor, or stress can be a second order or third order effect. And as with anything kind of indirect, especially a lot of cognitive phenomena, it can be really difficult to measure directly, right? You're trying to infer from observations. And so we'll talk later today about workload and some of the difficulties, kind of building off of what we talked about, I guess last Tuesday it was, difficulties in measuring those. And so what are things that fall into the environmental stressor category? So things like light levels being too low or too high, right? If you're really straining to read something, that can cause a certain degree of stress. And when we're talking about stress, we're talking about both psychological stress, right? The cognitive appraisal of a situation, but also purely the physiological stress, right? The body's response. You also have phenomena where you have fluorescent lights that long exposures to can result in things like headaches. You can also have motion-based stressors. This would be either sustained or cyclic, right? So motion that comes in cycles. We're thinking about things like high-frequency vibrations. So things like your lawnmower, the high-frequency vibration going through and causing physical stress, potentially damage long-term. Low-frequency vibration or oscillations, motion sickness, etc. Things like thermal stress, right? Being too hot or too cold has a range all the way from things like hypothermia to heat stroke or heat exhaustion. But even at lower or more moderate degrees, you can still have stress associated with prolonged exposure to heat or to cold. Air quality, so smell, lack of oxygen, smog. Right, so bad odors in an area. Up at high altitudes. Or like what they've got going on. My brother lives in Colorado right now next to a wildfire, and the entire sky is just like black. It's post-apocalyptic. That leads to a lot of stress, both physical and psychological. So psychological stressors are including things like the cognitive appraisal of situation. All right, this cognitive appraisal is really the most important thing for establishing whether or not something's going to be seen as good stress or bad stress. Are you seeing this stressor or this event as an opportunity or an unfortunate circumstance outside of your control? Are you seeing it as a challenge and an opportunity, or is it something dangerous? And purely shifting your perspective on these things can have massive impacts on your well-being, your happiness, and your stress level. But this sort of cognitive appraisal can also make the measurement of stress really difficult, obviously, right? If you have the same stressor affecting people differently, it's hard to know specifically what that stressor does to people. And there tends to be an inverted U function between the level of arousal and performance. Right? such that at low levels of arousal, you have weak performance. So you could think about this as right when you wake up, if somebody asks you some sort of math question, it's going to take a second for you to get your mind working, or you may need a couple cups of coffee for an hour before you can really perform at your peak. As you increase arousal to a point, you have increased performance, right? So think about this as like the game day phenomena, wherein on game day, you tend to perform better than you do in practice. All right, you're fully awake, you're fully alert up in here. But then we reach a point at which increasing that level of arousal diminishes that performance, right? So think about the extremes of overwhelming anxiety, right? That has effects not only on your cognitive performance, but things like muscle rigidity, and so you can no longer be as accurate with fine motor movements. You've ever had the phenomena where one of your friends will jump out and scare you right before you put your keys in the car or in the door? One of the things you'll notice is right after your hand starts shaking and you can't control it as well, right? So that's, again, that performance effect. So you can see, in the interest of maximizing performance, you want to find that ideal level of arousal. When it's game time or test time, you want to get yourself to that maximal level of attention and focus and ready to go-tude. In case you're wondering, that's not a real word. And not exceeding that. Oh, I'm sorry, Jenny, I didn't see your question. To use your game day analogy, when the crowd becomes too loud for the players, yeah. Or the situation becomes too big and they become overly anxious and then they choke in that situation. Exactly. If you guys want to see the world's greatest choke, which breaks my heart every time I watch it, go onto YouTube and type in Jean Van de Velde in the British Open. And I don't remember what year. I think it was the early 2000s. But he had something like a 3 or 4 shot lead going into the 18th hole for the British Open. I don't remember the exact sequence of events, but he hit his ball into a hazard. And normally you could just take a drop out of that hazard and hit it again with a penalty stroke. But for some reason he thought, no, I'll just hit it out, right? I'll advance the ball, it'll be good. He botched that. It stayed in the hazard. He botched it again, stayed in the hazard. Botched it a 3rd time, stayed in the hazard. I think he finally took a drop and then hit it. Wound up scoring like a quadruple bogey, tied, and then lost in a playoff. So that has nothing to do with class, but it's something worth watching. So anyways, there's a propensity to call this relationship the Yerkes-Dodson law. However, I will fail any one of you who calls this the Yerkes-Dodson law. Because if you actually go read the paper that everybody cites when they talk about this, the paper at no point mentions anxiety, at no point mentions stress, no point mentions performance, no point mentions arousal. It's about mice and shocking and how quickly they learn to escape from a maze. And so this is my own little rant, especially for all those of you in grad school. When I was in grad school, I had a propensity, and I still do kind of, to read other people's summations of articles rather than reading the article itself. And then it leads to some really awkward situations when somebody says, oh yeah, tell me about that article. Tell me how many times that article mentions stress and arousal. The answer is 0. I'm not really going to fail you, but just please, for the sake of my sanity, don't call this the Yerkes-Dodson law. Marquis says, not the Falcons from 4 years ago for that choking example. Yes, the Falcons from 4 years ago. That was a remarkable demonstration of choking as well. They? Oh, good. Awesome. Well, sorry for anybody who is a Falcons fan. As a Washington football team fan, though, I don't really care. I want all of you to be as miserable as I am. So, all right. So we can also start mapping at what point we start getting diminishment of performance. What you see here is a paper, or at least, I don't remember if this was initially a paper or if this was published in Colonel Grossman's book, but Colonel Grossman is a former Army colonel who has written extensively on kind of stress responses in combat, right? He's got 2 books on combat and on killing, on the physiological and psychological responses to combat and killing in battle. But some of his work has shown that you get this kind of incremental and then substantial diminishment of performance at varying levels of heart rate. And this is hormonally induced heart rate changes, right? So this is not you going and running and then having this diminishment. This is, oh my God, you're scared, and you get that hormonal stress response. And so you can see at about 115 beats per minute is when your fine motor skills start to deteriorate. So that's that example of putting the keys in the door I said before, right? You have a lot less dexterity and fine motor control over things like your fingers, small digits. The suggestion is that from 115 to 145 beats per minute is kind of that optimal survival range, right? So when we talked about the musculoskeletal system before and the circulatory system, right, this is where you start getting a shift of blood flow from kind of second order or second important things like digestion to the actual big muscle groups. Above 145 beats per minute is where you start getting complex motor skill deterioration. Right, so this starts to be kind of gross motor movements. At 175 beats per minute is where you start getting this cognitive processing deterioration, right? So you're no longer able to really focus on what's going on. Loss of peripheral vision, so this is that tunnel vision people talk about sometimes. Loss of depth perception, loss of near vision, so things in close. Auditory exclusion, so tunnel hearing, right? And so in the same way that you have tunnel vision, where you're excluding things on the periphery, auditory exclusion, or you're not hearing things in your environment. And then above 175 beats per minute is where you start getting your body going into like desperation mode. Right? So above 175 beats per minute is where you start getting that irrational fight or flight. Right? So if you've ever seen somebody in the really extreme ranges of physiological arousal, either being scared or feeling attacked or things like that, you may see them kind of lash out in unproductive ways. Freezing behavior, submissive behavior. You also get vasoconstriction. You also tend to get voiding of the bladder and bowels, right? So at this extreme rate, you'll sometimes have people who literally defecate themselves, not necessarily out of fear, it's just their body saying, okay, we got to void all systems so we can run faster, be more agile, etc. And then you have these gross motor skill degradations, so things like running, charging, punching, things like that, they start to deteriorate. So that overarousal, what we were talking about there, at about 175 beats per minute and higher, you tend to have this cognitive tunneling. All right, this is why sometimes witnesses to violent crimes tend to report not having seen things, even if they were right in the area of things, because of that heightened level or that overarousal. You can have working memory loss. Right? We tend to still be okay at pulling out well-rehearsed facts or actions. Right? So this is one of the reasons why there's so much training in high-risk environments, such that when you get this overarousal, you can still perform those tasks. And then we also find that people have strategic shifts, right? And so it's now no longer focusing on kind of what does that executive functioning tell me may be the best payout in the long run. It's I've got to do something now, right? If any of y'all have ever been unfortunate enough to have a panic attack, I've had a couple. You get this situation where all of a sudden nothing else matters. You just have to get out of that situation right then and there, right? So you remove yourself from that situation. There's not focusing on any of the second order or third order effects. You're getting the hell out of there. And those sort of strategic shifts can have consequences with that speed accuracy trade-off. Right? So now I'm focused more on that speed and less on the actual accuracy. So how do we measure stress? Well, we talked about this a little bit with workload. But one of the ways would be with the subjective measure. What's one reason, though, we may want to avoid using subjective measurements for stress?
Different people might handle it differently.
Yeah, so I think you are both hitting on the same point, right? With them being subjective, it's hard to know if your 5 is the same as my 5. Right? We all know those people who are so cool under pressure, and we also know those other people that really tend to overreact to everything, right? So is your 5 the same as my 5, or are people kind of subject to exaggerations, whether deliberate or non-deliberate? Andrew says self-reports might not reflect behavior. Yeah, and so it could be, again, that they are miscalibrated. Right? Maybe somebody wants to say, I'm at a 10 for stress, when in reality, there's a lot of way to go. You can do more objective measurements. So things like heart rate, galvanic skin response, EEG, eye tracking. So I'm sure you all are familiar with the idea of a lie detector test. And a lie detector tends to rely on that heart rate, that galvanic skin response. There are sometimes other things added in there. The problem, these are trying to do an objective measurement of your stress response, right? But there are a couple problems. One, you can have stress responses to the types of questions they'd be asking, right? Have you ever denounced your US citizenship? It's kind of an emotionally laden question in there. Even if I haven't denounced my US citizenship, maybe being put on the spot is going to increase my level of arousal in that situation. You also can, essentially beat this by convincing yourself of the truth. You also can have increases in heart rate and galvanic skin response that aren't tied to stress, right? And so these subjective measures are good, but they're not great. All right. So given the effects, oh man. Don't ever make that mistake. That's embarrassing. That should be an E, not an A. Given the effects of overarousal and stress, how might we design a secondary warning system, or one that may go off after a primary warning system has? Are you asking a question or are you stating? Yeah. Yes. So let's say you're in a nuclear power plant and you have an initial alarm saying something's wrong. And now there's a cascading failure. So there's a second thing that goes wrong after you're already in that heightened stress environment. What sort of things should we do in designing that secondary warning system? Help them.
Like an alarm and then like lights too.
Yeah. So
in college, our dorm had a fire alarm that flashed, which meant it was a warning. And when there was a real fire, it flashed and it said, "This is not a drill. It is a fire." So.
So making it extra explicit, right? So making sure that you're helping kind of, if there is any of this attentional narrowing or visual narrowing or auditory narrowing, that you're able to really present it in such a way that it's so salient you can't miss it, right? Adherence to those C's principles. What else? Yeah, and so Exactly. So in that case, you're really trying to minimize the amount of cognitive effort of looking at these different labels and say, what does this mean? You just know it's blink, or it's blink, blink, or it's blink, 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 etc. Yeah.
When I was in high school, I didn't sleep very well. I slept a little sleep. So I got this clock that was called the alarm clock. And it blares really loud noise, blinks lights, and it also has a function where it can vibrate. Then you put a little vibration thing under your back. So it stimulates you, so it's like, wake up, wake up, wake up.
Wow. Yeah. So it's multimodal in that case. Yeah. Yeah. Overload you to make sure that, yes, exactly. I've also seen alarms like that that are little just robots with wheels, and as soon as it goes off, it just darts around and you have to catch it and turn it off.
That was such a horrible way to wake up, though.
I think it'd be fun to be a game right off the bat.
Well, they have some alarms now that connect to your lights in your bedroom. So like after 5 minutes of it going off, if you're not awake, it turns the lights on in your room.
That's mean. That is mean. Denny says, salient but not too alarming to add more stress. Yes, exactly, right? You don't want to be put in a situation where you're already stressed because you have some sort of event going on. And now I'm going to present another event, but also, right, we've talked about how alarms can be annoying, right? They can have these kind of second order effects of being so overwhelmingly salient that now I can't focus on anything else except for that GD alarm. Exactly. Yes.
With the fire.
The fire's shooting at us. Yeah, exactly. All right, so it's kind of hard to see here. It'll be easier on the slides. But what you have is kind of an indication of the relative stress levels for different life events. All right, and so at the very top, according to this research, suggests that the biggest stressor you can experience in life is the death of a spouse. Right? Just below that would be divorce or marital separation. Right? Even if it's amicable, it's not necessarily without stress. Detention in jail, death of a close family member, major personal injury or illness. And then you have marriage, being fired at work, marital reconciliation, retirement, right? So any big life event involves some degree of stress. Even vacation can be a source of a stressor, right? Well, yes and no, right? I mean, there are going to be physiological responses to these types of stress, right? So prolonged increase in blood pressure, weight gain, things like that. So you can monitor both that subjective experience of it, but also the long-term consequences of those stressors. Good question. So in the words of Leslie Knope, watch out, it's all bad. The good news is we tend to adapt to stress really well. It's not just the case that we adapt to stress, we adapt to all things, right? So we tend to think that, you know, a year after winning the lottery, we would be a lot happier than we actually are, right? We get a spike in happiness and then we just return to our baseline. Find the same thing for like prisoners. There's a sharp drop off after incarceration and then a return to normal. All right, so now we're talking about workload. All right, so intuitively, we understand workload to be the time required to do something divided by the time available. And ideally, people like to keep this at or below essentially 0.8, right? And so don't fill up whatever that space is, that available space of time, with work to fill that entire time. Right, so if we look at this here, if we look at this graph here, on the y-axis, or excuse me, on the x-axis is that time required divided by time available equation. Right here at 1 says, okay, we have maximized the amount of work that you can fill for a certain time. And this is where you start getting that overload and degradation in performance, right? So it's not just that performance necessarily levels off or stays in line with what you would expect just from the amount of available resources you have, but the total is greater than the sum of its parts in this case, right? So overloading somebody has greater performance detriments than just neglecting of that extra work. Right, and that subjective experienced workload in here increases relatively linearly as you move across that ratio. And so obviously at a certain point, there's going to be diminishing returns. One obvious example of this is at a certain point, you just can't have any greater output. Right? You can only type so many words a minute. You can only physically make so many widgets an hour. And this is the issue with automation. Again, I know we've already talked about automation a little bit, right? We have this propensity to automate everything and then put a single individual in charge of supervising that automation. Well, what happens when that automation fails? Now, what was a normal workload has exceeded the workload capacity of that individual. Right, so I think about when I go to Walmart. Walmart now has a massive number of self-checkout stations, and they're getting away, or they're removing the cashiers, but they'll usually only have one person working that area, right? And that person's responsible for, you know, if they need to ID somebody or there's an issue, going and dealing with each one of those persons. But what happens when all of a sudden you have 3 systems that totally crash and restart? Or what if all of them crash and restart? Or what if all of them, you know, double charge at the same time, or things like that, right? So you now have created a situation where that one worker, rather than being able to maintain a relatively desirable workload, is being overworked, and you get diminishment of performance such that nobody is now able to check out. And so the question came up, and I am totally blanking on who sent me that email. So if it was you, please let me know. About test automation, right? So we talked about trust and automation a few weeks ago. And at that point I said, we're nowhere near fully self-driving cars, right? And then like that week, Tesla released what they called full self-driving, right? The problem is, that's almost entirely a marketing scheme. While it can do a lot more, the issue when we talk about full self-driving is that the car needs to have no human oversight. Because we're getting into exactly this problem right here, wherein if the car is now able to see the stop signs and stoplights, is able to make 90-degree turns, like this full self-driving module is, that's great, but I've now put myself in a position where I'm going to start engaging in some sort of secondary task, right? People don't just sit there and do nothing, right? We're either lost in thought, or we're on our phone, or we're reading a book, or things like that. And so now, when the automation fails, it's making that task switch to that primary objective while still dealing with the issues of the loss of situational awareness and things like that, right? And so for a car to be truly fully self-driving, we need it to not need the human whatsoever, right? It needs to have essentially full autonomy in the way that you have full autonomy.
Have you seen that viral video where it's like 3 boys in a Tesla and no one's in the driver's seat and they're all drinking?
Oh God, no.
It like went viral like 2 months ago, and they were like, "What can my cousin do?" And they were like all drunk, and there was no one in the driver's seat in like the middle of the night. I don't know.
It's, yeah. And again, it's one of those things that the system performs. I mean, the system is remarkable, right? It really does a lot of things. And there's a very good chance that you can get from point A to point B with having no interventions, right? I don't know Tesla's numbers, but one of its direct competitors that's seen as kind of, you know, if Tesla's 1A, this is 1B, OpenPilot from Comma AI, says that their equivalent system has about 1 unexpected event that the system can't deal with every 100 miles, right? That's far from being what humans are, right? We're pretty good at dealing with all sorts of events on a regular basis. And so, yeah, I mean, you know, in that case, I think they could still be charged with drunk driving because the expectation is that they should still be maintaining supervision. But, Jesus, that hurts my heart. Maybe Darwin was wrong. I don't know why people like that are able to exist. Sorry, that was too mean. All right, so talking about mental workload and not just physical workload here. The ratio of mental resources required to the resources available is how we're going to define mental workload. And time is not the entirety of it in the same way that we would talk about physical workload, right? And there are several ways we can measure this workload. One would be with primary task measures. Right, so how well are you actually doing on the task that you are meant to be performing? Right, because we know at a certain point, higher workload is going to result in a degradation of performance. And so now I can increase your workload or increase the task load with the expectation that it's increasing your workload until I start seeing a diminishment in that performance. One of the problems is, though, that there are ceiling and floor effects for performance, right? You can only get so good, right? If the task that you're naturally very good at, like chewing gum and walking, you can't really get better than that. Same with floor effects, right? Nobody's going to be able to perform an unbelievably convoluted task, and thus you can't get worse than that. You could do a secondary task performance measure. And the idea behind this is now I'm going to add a secondary task onto that primary task, which is essentially going to measure your reserve capacity. Right? So I'm going to see how well you can do this secondary task in tandem with that primary task. The problem with this is, you know, a secondary task is going to be intrusive by nature. So by its very nature, requiring a worker to perform this secondary task can have negative impacts on both the secondary task performance and that primary task performance. Also, by definition, a secondary task is not prioritized, right? So the performance on a secondary task is secondary to that performance on that primary task. Now you may say, just tell the person to actually focus on the secondary task, well, that now becomes the primary task and you've defeated the purpose. You can also do what's known as loading tasks. So perform some sort of loading task and make that primary task the secondary task. All right, so I'm going to increase that load step by step. Then you have physiological measures. So things like heart rate variability. So how much variability is there in those interbeat intervals? People also love to use EEG, so electroencephalograms. So for those of y'all who aren't familiar with kind of the principles of neuroimaging, you essentially have two different axes. You have temporal accuracy, right, or spatial accuracy. Right? And so I can get really good temporal syncing, right? So as soon as something happens, I can see what's going on in the brain. But that's usually at the expense of the specificity of spatial resolution, right? So I can see the onset of an event and the brain activity, or I can see kind of specifically where that brain activity is happening, but I can't really get a good temporal link. And so EEG is really good at the temporal synchronicity, right? It's good at telling you in that moment what's going on. Doesn't give you all that much spatial resolution. But there are a couple problems with it. First, it's obviously intrusive, right? Me putting something on your head, you're going to notice it's there. Frequently, with a lot of these systems, they also have a lot of wires coming off of your scalp. Right? So that obviously interferes with a lot of what you're trying to do physically. You can also affect those recordings just by participants knowing they're wearing an EEG cap, right? So when people know you're monitoring their heart rate changes. When they know you're measuring their workload directly, their brain activity changes. You also have an issue that anytime you're going to use an EEG, you need to have what's known as a workload classifier, right? Because all of these individual electrodes are giving you essentially just an electrical signal. What is that electrical impulse coming off the brain in this location? And you need to make sense of that, right? Because everybody has a different baseline. Everybody has a different high workload look. Yes, you're exactly right, Denny. And so you have to create this sort of classifier, which can be computationally and time-based, expensive. Or you can rely on the workload classifiers that a lot of these systems come with. However, they're proprietary and they won't tell you what they are, right? And so one of the biggest EEG systems I have used so far is what's known as the B-Alert system. And they've got a workload classifier, but they won't tell us anything about that classifier, right? And so we're supposed to base our assessments of workload on what they say workload is without us actually knowing. And so you have, obviously, some serious issues with efficacy and predictability. You can do subjective measures, right? And so this is, again, just asking people to rate their subjective workload. So most commonly used one is what's known as a NASA TLX. So doing any sort of workload assessments, you will probably come across this TLX. Obviously, the problem is, asking somebody to give a response while they're doing another task is going to increase their workload in trying to register that response. They also may not be truthful. They may not be a good judge, right? Ego can get in the way. You can also have workload dissociations, right? So all of these measures we've talked about don't necessarily agree with each other. It's kind of a big theoretical problem, right? If all of these measures are supposed to be measuring workload, you would expect convergence across these measures. But the fact that you don't have convergence across these measures all the time is a big theoretical problem. And when I say theoretical problem, I mean a problem with the theory of workload. But it also suggests that you should probably collect multiple forms. And wherein you do see convergence, you can have greater certainty that you are observing actual changes in workload. So you can help combat overloading by obviously assigning work to others, right? Offloading somebody by giving that work to other people. Automating part of the process, although we obviously talked about the consequences of automation. Develop displays, which are prioritizing the information for those people, right? We talked about the human information processing model. With that sort of decision selection part, we can automate that and make it such that the people don't have to make the decision. And then train for high time stress. Right, so train in events or in environments that are, in fact, high time stress. All right, we're running out of time, so I'm going to go ahead and just skip this. But I think it would behoove you, as we go into the final exam, to think about what are the tasks you feel are high workload in your environment? What about high mental workload? And what would you do to change those tasks to reduce that workload? Right, so things like cell phones and driving. You can converse well, you can drive well, but you can't do both well. Words of Ron Swanson, never half-ass two things, whole-ass one thing. All right, so one of the big issues when we talk about mental workload are things like vigilance, fatigue, and sleep disruption. Right? And vigilance tasks are tasks wherein I have to be paying attention for a long period of time. Maintaining that sustained attention in those high vigilance tasks can be really exhausting. Right? Just think about, your study days as you lead up to finals. The end of a day where you've been paying attention the entire time and exhausting your brain, you feel exhausted at the end of it.
I have a question.
Yes, what's up?
So does that mean more like in terms of a single day, like 12, like if you work 12 hours, by the end of the 12 hours, you're really tired? Or could that be even over longer periods of time? Like, for instance, if you're working full time and you're going, working on your master's and maybe you have some other things going on and you're working for like weeks at high levels of stress or attention.
Yeah. So we're going to talk a little bit about things like sleep debt, right? And so kind of continuous sustained overexertion can pile up and add on to one another. And so these sustained vigilance tasks are talking about more kind of in the short term, in the sense that if you have sustained vigilance over a period of time, you tend to get diminishing performance. However, sustained vigilance with inadequate repair or sleep or replenishment of your resources can lead to essentially a lower 100% bar, if that makes sense, for performance. Or burnout, yes. Yeah, you do have the issue of burnout. And we'll talk about sleep deprivation in a few slides here, but I'm trying to remember the exact numbers. 17 hours of sustained wakefulness, right? So 17-hour day where you are paying attention, you're cognitively engaged, can lead to cognitive impairments equal to a blood alcohol level of 0.05. 24 hours is equivalent to a 0.08, right? Or a 0.1. I think it's a 0.1, right? And so this is why I always tell, especially my undergrad students, grad students seem to be a lost cause at this point, but undergrad students, that pulling all-nighters is not a good thing, right? If you would ever decide to go take an exam drunk, I think everybody would tell you you're insane. But if you ever went to go take an exam after over 24 hours, which has the same cognitive impairments as being drunk, everybody says, wow, you're a hard student. That's insane. Hard-working student, excuse me. And so you have things, types of jobs that are specifically, essentially, vigilance tasks, right? TSA screeners, that's the vigilance task. And that could help explain why you have things like this. An internal report just a couple of years ago, 2017, found that 95% of tests given in the TSA screening were failed, right? And this is things like the testers putting in fake guns or bombs or things like that. I would normally say, I hope none of y'all have flights anytime soon, but at this point in the world, nobody has flights anytime soon anyways. So, but you do have these kind of sustained vigilance tasks, right? It's an inherently difficult task, right? For 8 hours a day, you're looking at screen after screen after screen with a really low true positive rate, right? There are very few weapons that are ever going to come through there. So there are all sorts of issues associated with that. So several components can cause vigilance decrement. Right? So after only 20 minutes, you start seeing a vigilance decrement. So 20 minutes on that baggage screening, after that, I'm going to start seeing deterioration of performance. Yeah, exactly. Denny says long doctor shifts in the hospitals. Back when my mom was in med school in her residency, they had 36-hour on, 12 off shifts. So it'd be 36 on, 12 off, 36 on, 12 off. They then shifted it to be 24 on, 24 off, 24 on, 24 off. And this will be kind of a bigger issue when we're talking about sleep deprivation. But then they realized that one of the downsides of doing the 24 on, 24 off was that doctors were not learning how to make decisions under extreme sleep deprivation, which is sometimes the case in a lot of these hospitals. And so there's been kind of a movement to go back to the 36 on, 12 off shifts. So event salience, right? So every time we talk about salience and sieve and noticing, low salience, it's going to lead to higher errors, right? Hidden weapons in that TSA example lead to higher errors. Signal rate also has a massive contribution, and that's that example of what I was just talking about, of that kind of true positive rate. So how frequently can I expect to see a weapon in that TSA screening task? Right? A really low signal expectancy can lead to what we call black swan events. Right? So a one in every so often event. Those black swan events are really dangerous, especially in high-risk environments. Right? It's that one time somebody does bring a gun through TSA where you then have a problem. And then arousal levels, right? Low level of arousal puts that operator at that far left of that inverted U curve, right? So making sure they're getting the coffee, they're getting the opportunity to get up and move around, etc. So how can we deal with vigilance decrements? Make the watches shorter, right? Give frequent breaks. This is why at the TSA, you'll see frequent rotations through the different stations. When possible, signals should be made more salient. So highlight possible defects. This is now why for the TSA, and I'm going to keep going back to TSA because this is a classic vigilance example. This is why the screening will now have color-coded representations on screen for different densities of material, right? So it's easier to see a metal object. Changing the criterion or bias for the operator to incentivize hits, right? And so when we talked about signal detection theory and having that decision criterion, it would be much better to have, in the TSA example, a false positive than a false negative. So change it via some sort of incentive structure, reward structure, etc. And then create or sustain a higher level of arousal. So things like breaks, obviously, caffeine. The Air Force used to, and they may still, although there was a lawsuit that was happening, administer what were known as go pills, right? And this was essentially low-grade methamphetamine that they were giving pilots to help them stay awake for long periods of time. One of the reasons I'm not sure if it's still something that they give out to pilots is there was an issue in either Afghanistan or Iraq, I don't remember which one, in which a pilot essentially engaged their weapon system on friendly forces, killed the friendly forces, and blamed it on the go pill, saying, it made me so jittery, I overreacted in there. So it's not always the best idea to give pilots meth, essentially. All right, sleep. Sleep, sleep, sleep. So sleep disruption includes the effects you see with getting less than that recommended 7 to 9 hours of sleep. Right. The amount of time required for you to be asleep is going to vary individual to individual, but also at different ages. In your early 20s, you're still having a lot of frontal lobe development, right? And so during the stages of life where you have a lot of brain development or neural pairing, right? So the removal of neurons that you're not using tend to result in longer amounts of sleep needed. You can also see differences in sleep patterns throughout your circadian rhythm, right? That's why it's a lot easier for you to sleep at night if you've got a regular schedule than it is to sleep during the day. However, you can also have disruptions of circadian rhythm from things like jet lag or shift work. Right? We tend to have a circadian rhythm, that rhythm throughout the day, of between about 23 and 25 hours. It varies from person to person. But if your body's expecting to go to sleep at 10 o'clock at night, and now all of a sudden you're starting your work at 10 o'clock at night, you've completely disrupted that circadian rhythm. You're going to have performance deficits during that period where your body's expecting to be asleep, and you're not going to be able to sleep as well the next day.
I have a question, Nate.
Yeah, what's up?
Do you, I was just thinking about Thomas Edison, where I remember hearing a story that he slept in shifts and would have assistants wake him up at inopportune times because he felt like he would be woken up like right in the middle of REM sleep. And so his dreams and these inventions would come alive. I wonder if there's any truth to that, or if that's just hogwash and he was, it was just an anecdote.
Let me preface this by saying, far be it for me to tell Thomas Edison that he was an idiot. I think in that decision, I don't know if that necessarily makes sense. I think that there are, you know, I see the argument in that case, but I think the consequences of being woken up in the midst of REM sleep may kind of outweigh the benefits associated with it. There are other things, like Einstein worked in a patent office because he knew even before kind of the research supported it, that kind of meniary work or repetitive work that doesn't take a lot of focus can actually help increase your cognition. And so there may be research out there to suggest that what Edison did was right, but I kind of doubt that would be an overall benefit. But again, he's Thomas Edison and I'm not, so. So like I already said, the all-nighter hurts performance, right? So that's sustained level of attention, a sustained wakefulness. Obviously, sleep deprivation, I mean, I'm sure everybody in here has been deprived of sleep at one point, and you kind of know the effects of sleep deprivation. But things like higher level cognition, your ability to reason, to make sense of things, your decision-making. And this is why I think perhaps Edison was wrong, kind of that innovation and creativity is hurt with sleep deprivation. The ability to learn and store new material, right, to synthesize information. Maintaining situation awareness, multitasking, etc. So here was the study I was talking about earlier. So 17 to 19 hours of wakefulness corresponds to a BAC of 0.05. Longer periods, which corresponded in that paper to 24 hours, was a BAC of 0.1, right? So over that legal limit of drunkenness. And so this is why you've seen some industries, like airlines, mandate specific requirements that pilots can't go over. They can't be in the cockpit for longer than X number of hours in a week, right? With the hopes that this is going to diminish any sort of performance effects. Same with truck driving, right? You can only drive for a certain number of hours and then you're required to stop. But in other environments like the military, there tend not to be those same restrictions. All right, and so my favorite example, my cousin graduated West Point and then went to Ranger School. So the Army Rangers is one of the special forces branches. And for about 60 days, they average about 3 hours of sleep a night. And so by the end of it, they're so sleep deprived that he was telling me stories of soldiers that were hallucinating, doing things like standing behind trees thinking they were in formation, or thinking they were putting dollar bills into a vending machine when in reality they were just trying to jam their fingers into a tree, things like that. And sustained circadian rhythm disruption can lead to a lot of negative health consequences. All right, things like cardiovascular disease, obesity, ulcers, depression, increased risk of accidents and injury. Right, and so shift workers, especially people like nurses, are particularly susceptible to this, right? After a night shift, on the way home, they crash. Also things like diabetes, in the words of Wilford Burnley. All right, so what can you do to get over these sort of sleep disruptions? Well, obviously, first and foremost, get more sleep. That's obviously not always feasible. So where impossible, sneak in a nap, right? And it's kind of hard to see, but there are napping guidelines here. Let's see if I can read these. So the 10 to 20 minutes is good for boosting alertness and energy. 30 minutes is where you kind of get into the danger zone, causing that sleep inertia and that kind of hangover feeling of you waking up and completely disoriented. 60 minutes is best for improvement in remembering facts, faces, and names. And then 90 minutes is that full cycle, that full REM cycle. And so as kind of Hope was talking about with the debts you can accrue in sleep, you can also build up a little bit of sleep credit, right? If you know you're going to have sustained periods of lack of sleep, getting and building up those hours of sleep ahead of time can help a little bit, right? It's not the case that I can sleep for 48 straight hours and then go a couple weeks without sleeping. Stimulants, so things like coffee, are effective in the short term, but obviously not the long term. And then prohibiting work at late times.
So is it true you can make up for lost sleep at a later time?
Not in full, right? So you can make up a little bit, right? And so if any of y'all have had sustained periods where you've only been getting maybe 4 hours of sleep a night, once you get the opportunity to sleep a full night, you may sleep a little bit longer, right? And you can help build that up, but it's not necessarily the case that it is like a running debt clock in the sense that, you know, I'm now 490 hours in deficit and I can make it all up. So it does help a little bit, but not in full. I always love this sign here of that no crime from 8 a.m. to 6 p.m. I always thought that was in jest until COVID. And then I don't remember, it was some international city. I don't think it was in the US, but essentially put this out and saying, nobody's allowed to commit crime between these hours because police don't want to be out. Like, okay, well, that's one approach. Cool. All right, so got just a couple minutes left. What were the main takeaways from today's lecture? Was that? Yes, get sleep. Yeah, I always loved when I would give this lecture to my cadets at the Air Force Academy. They would look at me cross-eyed and be like, come on, that's not possible. Or grad students, I guess. Very similar.
Stressors can be psychological and physical.
Yeah, so you can have psychological stressors, you can have physical stressors. Exactly. Give me an example of a physical stressor. So that could be a physical stressor, but I was more thinking of like temperature changes, right? So that's a physical stressor. A stressor. Yes. Yeah, what else? What were other takeaways? Balancing workload, yes. To reduce stress, but the physical workload and that mental workload. What else? Make lifestyle changes to, yes. Yeah, so, I mean, a lot of this is probably what you would think of just be organized, make sure that the amount of work needed to accomplish doesn't exceed the amount of time to accomplish it, or there are resources to do so, get sleep. Also things like cognitive appraisal, right? And so don't look at an event like an exam as a threat to you, right? Don't see that exam as, oh my God, if I fail that exam, I'm gonna fail out of school, my parents won't love me, I'm gonna be homeless, etc. Right? Don't catastrophize like I'm sure we all do. Right? See it as an opportunity to prove yourself, right? If you think about that as an opportunity to prove yourself, you're gonna have not only a better stress response, but actually better performance on that test. All right.
I think, well, I was just going to add,
Yeah.
you know, our culture is like we give 100% or 110%, you'll hear a lot. And it's interesting that the ratio is actually 0.8. If you give just a little bit less in the long term, you're actually going to come out better.
Yes. Although I don't think it's a very inspirational speech to say, give 80%. You'll be fine. Yeah. No, you're exactly right. Yeah. So for that long sustained duration, obviously there are peaks and flows or peaks and valleys in kind of work, right? I think anybody who's worked a job, especially grad students at this point, and I keep hammering on grad students because all have had that experience, but where you have to go weeks on end with only getting 4 hours of sleep a night working on your thesis or dissertation, and then you can kind of go back to that normal workload. But exactly. All right. If you have any questions, let me know. Otherwise, Boeing team, hang out for just 2 minutes so we can really quickly talk. And I will see the rest of y'all on Tuesday. Thursday. I don't. In my mind, it's still March. I don't know how it got to November. So. Yes. No. Come to class. Yes, ma'am. Thank you. All right. 1 second here.
Okay, while we're waiting on and whatever,
Mhm.
I was gonna email you, but I won't be physically in class next week.
Unacceptable.
I know, well, Austin and I's wedding is next weekend.
Is it?
So
Oh, that's awesome.
We're going home to like get our shit together.
Congratulations.
Thank you.
Where's the wedding going to be?
In Auburn,
Oh, nice.
so.
That's awesome.
Doing it remotely next week.
That seems reasonable. Have a good wedding.
Thanks. I'm hoping for really nice weather, we'll see.
Yeah. Yes. All right. Cool. So let me go ahead and